Hello everyone, welcome back to my channel. I'm your host Asma, and today we've got an exciting exploration ahead. We're diving into the world of Python and the bisection method. Now, I know coding might sound challenging, but stick with me. We're going to make it easy and fun. So what is the bisection method? It's an iterative algorithm that's like a detective hunting for the root of a function within a specified interval. Its main purpose is to solve equations where the exact solution cannot be obtained. The bisection method approximates the root using numerical calculations. Let's break it down. Say we've got a mathematical function x cubed minus 5x minus 9 and you want to find where it equals 0. The bisection method takes a guess and check approach, refining its estimate until it gets close to the actual root. Here's a sneak peek at what goes on. Firstly, we initialize variables. We set up our algorithm, creating a function to represent the mathematical relationship. Secondly, we do iterative refinement. Within a while loop, we calculate the midpoint between initial guesses and update our boundaries based on the sign of function values. Third, we print out the result. The algorithm keeps refining until the absolute function value at the midpoint is within our specified error. Fourth, we ask our user for the input values for initial guesses and the error we are willing to tolerate. Fifth, we execute the bisection method. The algorithm runs with these inputs, showing us the step-by-step process and the final approximation of the root. I encourage experimenting with different inputs to see how they affect the convergence process. Let's have a look at our Python code. In this code, a bisection method is implemented to find the root of the function x cubed minus 5x minus 9. The initial steps involves defining the target function fx, which encapsulates the mathematical relationship. Subsequently, a function named bisection is introduced to execute the bisection method. In the function, the first steps include initializing variables such as the iteration counter, that is step, and a Boolean condition for the iterative process, that is condition, and a message indicating the start of the bisection method. The core of the bisection method occurs within a while loop where the midpoint x2 between the initial guesses x0 and x1 is calculated and displayed along with the corresponding function value. The algorithm then adjusts the guess boundaries based on the sign of the function values at x0 and x2. If the product of these values is negative, indicating a change in sign and the potential existence of a root between x0 and x2, then x1 is updated to x2, otherwise x0 is updated. At each iteration, the code increments the step counter and updates the loop condition based on whether the absolute value of the function at x2 is greater than the tolerable error, that is e. The loop continues until the condition is no longer satisfied. Following the iterative process, the code prints the final approximation of the root. In the main part of the code, the user is prompted to input their initial guesses and a tolerable error. The bisection method is then invoked with these user-defined parameters, and the algorithm's progression is displayed at each step, offering transparency into the root finding process. There you have it. The bisection method was used to find the root of a cubic function with an initial guess of -2 and a second guess of 3, aiming for an accuracy within 0.3. The algorithm iteratively narrowed down the possible root, calculating a midpoint and adjusting the bounds based on function values. After 5 iterations, the method found that the root is approximately 2.84375 with a corresponding function value close to 0. The process effectively demonstrated the bisection method's ability to converge towards a solution within the specified tolerance. Users can experiment with different guesses and tolerances to observe how these choices impact the algorithm's behavior and the accuracy of the result. That wraps up our exploration into the bisection method using Python. I hope you found this coding both insightful and applicable. Thank you for watching, and I'll catch you all in the next one.